Hi, everyone. Thank you for joining us for today's webinar. We're going to allow a few more moments for people to funnel in. Feel free to use the chat panel at the bottom of your screen to chat with other participants. We'll be giving you some more instructions as the time passes soon. Thank you, everyone, for joining us. We're going to allow 2 more minutes for people to register and filter in. Please feel free to use the chat or Q&A panel to submit questions during today's call.
Well, hello, everybody. Again, this is Perry White. I'm the West and Mountain Zone product trainer for PPG. We want to thank everybody for being online for this first of a new series of webinars that we're going to do. We're going to start out today with Paint 101 and basically let you know what's in the can. So our objectives today is really understand and learn what the 4 primary ingredients that make up the majority of our paint products. Paint is one of those things that you really get what you pay for. And when you have different price points for paint, it really does drive customers' expectations of what's in the can. And so again, some products might have similar formulas, but that doesn't really mean that they're the same products. So again, we're going to really kind of break down the differences between products that are using lower quality materials and products that make up higher quality materials. Like Kate mentioned, if you need to ask a question, you can put it down into the Q&A box and we will log those, and then at the end of this webinar we'll have about 15 minutes for Q&A. Also the chat function can be used and Kate's going to be monitoring that. So again, when you talk about what's in a can of paint, there's basically 4 main ingredients. By volume, typically for regular house paints, the main ingredient is the solvent. And this can be water if it's water-based, or mineral spirits or paint thinner if it's an oil-based product. But this provides a mean for the pigment in the binder to be applied to the surface. We have dry pigment products like powder coatings, but most of the paints that we sell are fluid applied. So the solvent is a big deal, and we'll break that down. The binder, or the resin, literally binds the pigment together. And this is what gives your paint film integrity and adhesion, durability, moisture resistance, hand oil resistance, things like that. Additives are low volume ingredients that provide specific paint properties. So those things could be mildicides or rheology modifiers or surfactants. Again, there's not much of those in the can, but it's really amazing on how those typical additives can really change how a paint works. And then the last part is pigments. And these are the things that provide color and hiding properties. And they're extender pigments that are used to add body to the paint while keeping manufacturing costs low. And we'll talk about pigments right off the bat. So when we think about pigments, there's basically two types of pigments. You've got your main prime pigments, and then you've got extender pigments. Again, these things provide color and hiding properties. Some are used to add body to the paint while keeping manufacturing costs low. Pigments are basically flattening agents, so they also help determine the gloss or sheen levels of paint. And then titanium dioxide, which is a main prime pigment, provide whiteness and brightness. So again, pigments fall within these 2 categories: prime pigments, which are your main sources of hiding, and extender pigments. So when we talk about prime pigments, they're the ones that give us both whiteness and color. They're the main source of wet and dry hiding once the paint is applied. If you see that pile of white powder on the left, that is finished dry titanium dioxide. It's the predominantly white prime pigment. The chemical number is TiO2. Again, it gives you brilliant whiteness. It gives you excellent coverage, both wet and dry. Wet hide is when you're initially applying a paint onto a substrate. Your more premium products, especially those that are 100% acrylic, typically have a very high titanium load, and they will give you the best initial wet hide, and then ultimately they're going to give you a very good dry hide. And again, these molecules are very large and very round, so this brilliant whiteness is the result of its unmatched ability to scatter light across the entire spectrum of light. So when when a light source hits a very white paint film, it scatters the light and makes it very hard to see any type of surface imperfections. Darker colors don't have that brightness coming back at you, so with darker colors, you can see surface imperfections sometimes. So when you get to the colored pigments, there are basically 2 subclasses. There are natural pigments, or organic is what we call them. They're naturally occurring, and examples include white titanium dioxide, carbon black, yellow oxide, red oxide, and raw umber. Titanium dioxide contributes to about 60 to 70% of your raw material cost. And the reason for that is that the titanium ore coming out of the ground isn't white. And there's very few places around the world that actually where titanium ore exists. So they have to go through a lot of chemical processing and cleaning to get it to that white titanium additive that we get when we're making paint. And you'll find more titanium in your white tint bases than you do in your mid-tone or your ultra deep bases, which literally have no titanium in them at all. That allows the colorants to move. Natural pigments are very good for UV resistance. So many of our colors, especially if you look at the Voice of Color palette, if there's a large amount of natural pigments in there, we will recommend them for outside. Synthetic pigments are man-made pigments, and these include your phthalo blue and green, your durable red, your fast yellow, magenta, and violet. These colorants are very bright and vibrant, but they don't hide very well, and they're not very UV stable out in the sun. So you have to make sure that if you've got a high load of synthetic pigments in a formula, typically off the Voice of Color, you'll see a little sun with a line through it, and that's a recommendation that that product might fade over time. And it doesn't matter whose product you're using, everybody uses very similar synthetic pigments, so those really bright, vibrant colors should probably not be recommended outside. The other type of pigments that we talk about are extender pigments. So when you talk about good, better, best in the continuum of all of our paints, when we have to get to a very entry-level price point product, instead of a higher solids content of acrylic resin or titanium dioxide, we have these extender pigments, which gives the paint bulk, and it makes it look like paint, but we save quite a bit of money in the can. For example, Speedhide Pro EV Zero is a vinyl acrylic resin or binder with a fairly high load of extender pigments, which brings that cost down. Or Multi-Pro Maintenance might be that type of a product. These lower cost extender pigments don't hide as well compared to titanium dioxide. They don't give you that initial wet hide, but typically they do pretty good with dry hide. Again, we will add extender pigments in small amounts to more premium products if we want to alter the gloss, change the burnish resistance where it doesn't get shiny if you're washing on a flat paint, if we're trying to improve scrubs, improving touch-up, or flow and leveling. All these characteristics can be altered a little bit through the use of extender pigments. The most commonly used extender pigments we have would be clay or diamascus silica or silica, and those silicas are actually what gives you better washability because they're kind of slick. Trying to get wet hide, calcium carbonate is basically drywall mud, and again that helps it hide kind of like mud because that's kind of what it is. And then a lot of our primers or block fillers have talc in them. If you think about powder sanding a primer to where it gives you that really smooth finish on trim and cabinets and stuff like that, it's actually the talc that's in that primer that gives you that really smooth finish. So all of these extender pigments are very important when we make paint. And again, they all bring different characteristics that somehow affect the performance of the paint. So that's pigments. With binders, binders again literally bind the pigment together and they give your paint film integrity and adhesion. And so again, the types of features that you get determine the quality of the binder. And again, the many different paint properties that include adhesion, where 100% acrylic resin has the best adhesion compared to like a vinyl acrylic resin. Scrub resistance, because the paint is tighter and more durable and more washable and more scrubbable. For exterior, you've got better chalk resistance, fade resistance, and crack resistance because homes have a tendency to thermally expand and contract. 100% acrylic resin has phenomenal, it's not an elongation property like an elastomeric, but it will move so that you don't get that chalking, fading, and cracking. And then flow and leveling, more premium resins will give you better flow and leveling. And then the higher the level of resin affects the sheen. So if you had a binder that had without any pigment added to it, that coating would be clear and glossy. So again, the sheen level of a binder is reduced as the amount of pigment increases in a gallon of paint. And we'll break that down a little bit more. So your core products, if you've got an oil-based paint, and I know there are many parts of the country that are VOC restricted, so you don't get to use them as much, but oil-based paints were literally how paint used to work, prior to 1900. So the binders and oil-based coatings are made from either a vegetable oil, such as linseed, soybean oil, or a modified oil called an alkyd, which actually occurred back in 1923. So oil-based binder film formulation. As the paint cures, we call alkyd or oil-based paints, the curing process is called oxidation. So when you apply the paint and the liquid solvent evaporates, it leaves behind the binders and the pigments. This is the volume solids. The binder then oxidizes or reacts with the oxygen in the air. And so it actually, being exposed to the elements, oxygen, that paint film will get harder and harder and harder. And that's why people like oil or alkyd-based paint sometimes, because they have that great pencil hardness, which gives you good abrasion resistance and durability. So that's why oil-based paints are still very popular. The problem with alkyd resins or oil-based resins is that even though the oxidation process slows, it never stops completely. So as oil or alkyd-based paints get older, they get harder and more brittle over time. And oxidation also affects how the paint looks, because a very bright white will start to amber or yellow, and especially indoors, like on cabinets or the inside of cabinets, they become very yellow over time. You actually can't touch up a lot of oil-based paints, sometimes as early as 6 months, because that oxidation process occurs so quickly, they start to get more yellow than the paint that's still in the can. So you have to be a little bit careful with that. That's why it's kind of an older technology. But again, in some parts of the country, people still swear by oil-based paints. They have a lot of solvents in them and a lot of VOCs, which gives you slower drying and a lot of smell. So again, they're kind of old technology. So when we talk about all of our water-based products, the film cures through a process called coalescence. So binders and latex paints coatings that are solid, they're plastic-like materials, and they're dispersed as very small microscopic particles. So it can be acrylic, vinyl acrylic, and styranated acrylic. So those are all very common types of products that we make. So if you look at the little picture in the left, you've got the water and the additives, which everything's suspended in. You've got the pigment particles, and then you've got the latex or acrylic particles. So again, latex-based binder film formulation happens with two processes, evaporation and coalescence. You apply the paint, and the liquid solvent, which is water, evaporates. It leaves behind the binders and the pigments. And again, that's the volume solids. As the last liquid evaporates, the binders and pigments draw very close together and just get tighter and tighter and tighter and tighter. So the binders and pigments draw so tight that once all the solvents evaporate, they fuse or coalesce, and then you've got one completely continuous paint film. So that's why paint looks so good. Water-based paints are definitely the direction that the industry's been going in many years, and water-based paints have some advantages over oil-based paints for color and gloss retention and flexibility. So again, when you talk about different types of binders, acrylic or 100% acrylic are our most expensive products. It's the most commonly used premium product resin would be 100% acrylic. They get hard, but yet they stay flexible, and they're very crack and peel resistant, especially outside. They're very water resistant. So when people say, I am painting a bathroom or a kitchen, where you know you're going to have a lot of splash, you instantly want to get them into a more premium product that's 100% acrylic, because it's going to be much more durable, washable, and more moisture resistant. That's why all of our exterior products are 100% acrylic, because of that constant exposure to moisture. 100% acrylic resin has very good UV resistance. Again, that's why you want 100% acrylics on your exteriors. They have very good adhesion and film build. 100% acrylic products, again, are typically more premium products that have a higher volume of solids, and they have the ability to have better sag resistance, and again, they're the best for adhesion, so that's why they're more expensive. They have good blocking properties and stain removal. So blocking is when you have two painted substrates, say a cabinet door and then the cabinet face. Once you paint them and let them dry, when you close the cabinet door and those two painted surfaces touch, if they open up again and don't stick to each other, that's called good block resistance. 100% acrylic products have inherently good block resistance because they dry fast and they dry hard. A product like Breakthrough is one of our best products for drying quickly and hard so they don't stick together. And the film gets so tight that stains aren't able to embed themselves in the pores of the paint film. So you get good stain removal, where the stain basically just sits on the surface. And a product like Manor Hall or Regency or Silk & Touch all have this stain repellent ability, to where the film is so tight, stains just kind of ball up like water on wax. Excuse me. 100% acrylic paints are also very alkali resistant. And that means they don't react with high pH levels or salts that are inherent in any type of concrete or masonry product or stucco. So again, 100% acrylic primers and top coats do very well for alkali resistance, and then they're the most durable, that give you the most scrubs and resist dirt pickup the most. So that's 100% acrylic resin. Vinyl acrylic resin is great for interior work, and especially when you're in a cost situation Excuse me. So they're going to be built to be a little less expensive. The film itself is softer but washable. Not all stains are removed. And so again, they work fine in kitchens and baths, but they're not going to be the same as 100% acrylic. So some stains might stay embedded. Excuse me, folks. They have good to fair water resistance and durability. So again, you wouldn't put these outside. And then they've got fair to poor UV resistance. So you don't want them outside because the film erodes. So you have to be careful with that. So epoxy resins, and we're not going to get too deep in this today, but epoxy resin is a two-component product, and it's typically used for industrial uses and marine uses. These products combine to form an epoxy resin with a curing agent or cure or hardener. So again, you've got a part A and a part B that are mixed together, and you have a chemical cross-linking. The product cures by solvent evaporations, and then these two chemical parts A and part B start to attach to each other, and it gives you a lot more adhesion because of these different reactive sites and stuff. So again, these products get so tight and so hard, it gives you excellent chemical and water resistance. It gives you amazing abrasion resistance, and for interior, very good durability. Now, epoxy resins in general, if you put them outside and they're exposed to UV, have very poor exterior color and gloss retention. They will actually start to get chalky and start to fade or change color very quickly because the nature of epoxy resins, and this goes for anybody's product, it's just they don't do well with UV exposure. So even though it gets chalky and the color fades, the one thing about it is, though, is that you won't lose any of the chemical resistance, you won't lose any of the corrosion or rust resistance, and you won't lose any of the abrasion resistance. The product is still going to be hard, it's still going to be durable, it's still going to be chemical resistant, but aesthetically it's not going to look very good. So for that reason, we typically top coat epoxies with polyurethanes. It's a similar product where it's a two-component product, again, used as a top coat for ultimate color and gloss retention, but most polyurethanes are carcinogenic. The part B cure contains an isocyanate complex, and that's what makes urethanes have a very powerful smell. A lot of times if you're trying to use urethanes inside, you literally have to evacuate everybody that's in that space, and the person applying the product needs to use a fresh air system to make sure that they're not breathing in any of these isocyanates, because it is carcinogenic, can cause cancer. But again, they give you great chemical resistance. Urethanes cure just like epoxies, but they have a couple of different characteristics. There are some urethanes out there that cure with moisture that don't need that part B component. They actually absorb humidity and moisture out of the atmosphere, and you have to have that to get it to cure. Or they react with a catalyst, where you've got your part A resin and your part B hardener or cure, and you always add the hardener and cure, the part B, to the part A. So the difference between epoxies and urethanes is that urethanes are very light stable, so they're great for exterior exposure. They're non-yellowing, even a bright white. They have superior gloss and color retention, but even though they're hard, they do maintain flexibility, especially if you think about on a metal building or a tank or exterior handrails or anything that's exterior. They have a little bit of flexibility, and they're very chemically resistant. One thing about epoxies is that epoxies can be put underwater in immersion areas to where polyurethanes cannot. Polyurethanes are always for above ground application, above the waterline application, to give you that ultimate color and gloss retention so that aesthetically it stays good looking for a long time. Interior, urethanes look good for a very long time. So just know that's the difference between epoxies and urethanes. So let's talk about the solvents next. So the most common solvents, if you're using an oil-based paint, would be paint thinner. That is the basic primary solvent for oil or alkyd-based products. Again, we've had so many VOC restrictions over the years in different parts of the country. And again, because alkyd products have a tendency to lose their color and sheen outside, we're really kind of moving away from these oil-based products. Denatured alcohol, think of bin shellac. That's the main solvent for any type of shellac-based products, whether it's a clear shellac or a pigmented shellac. Denatured alcohol is one of the best solvents for locking in animal smells, like animal urine that might be embedded in a floor underneath a carpet, or any type of smoke damage where an oil or water-based product might lock in the stains from smoke damage, but they typically don't lock out the smell. So whenever you're trying to do smoke renovation or animal encapsulation of smells, a denatured alcohol solvent with a shellac product is going to be the best. Lacquer thinner is the primary solvent in lacquer-based products. And think about something that's a very hot solvent, a very quick-drying product. If you're familiar with lacquers at all, those products are typically used for interior furniture and millwork. They're not really for outside use. They don't do well in sun exposure, and they're not very good in high moisture areas. But again, think about, you know, wood cabinets, wood trim based crown molding and things like that. You literally can recoat these products about every 15 minutes, and you really try to get typically 3 to 4 coats to get that nice deep furniture look. And so again, lacquer has very high VOCs, not in use as much anymore, or it has to be applied in a very controlled atmosphere, typically in a spray booth where they can kind of scrub the solvents as they come out. But for the most of us, the primary solvent that we deal with for latex or acrylic-based products is water. So that there are a certain amount of solvents. Typically, you know, a majority of our water-based products are less than 50 grams per liter to be able to be sold in every VOC restricted area around the country. And then we have zero VOC products that don't have any solvents in them. But again, the water is going to be the main one. So you clean up with water. If you need to thin it out just a little bit, you would use that. So again, the purpose of solvents in paint are basically used to dissolve or disperse the binder. Some people think that the pigments really get dispersed in the solvents. They don't. The pigments stay solid, but it's the resin or the binder that gets dispersed by the liquid. So it provides a means for the pigment and binder to be applied to a surface. So you can spray it or brush it or roll it. The solvents will control the viscosity of the paint or how thin or thick it is. And that will influence the rate of drying and the flow and leveling properties. So again, the solvents are very important for how the product actually applies. Solvents also aid in the film formulation of latex paints. They're coalescing agents or dryers that can be part of that less than 50 grams per liter in many products. So again, you do have some solvents that are in there which will contribute to volatile organic compounds or VOC emissions. So that's the smell that you get. So an example of these types of solvents would be butyl cellulose, ethylene glycol, which is like, what am I saying? Is like radiator coolant, xylene, and mineral spirits. Those are all examples of the types of solvents that would still be in a water-based paints, but in small amounts, less than 50 grams per liter typically, but they make the film cure properly. They aid in the film for low temperature exterior paints and things like that, and help with the flow and leveling. One misconception about drying for paint is that a lot of people think temperature is the main thing that affects how paints cure out and dry. And it is a big part of it. And most of our products all say that they dry, for example, at 77 degrees in 1 hour to touch, 2 hours to recoat. But that is at 50% relative humidity. And so humidity is really one of the things that really affects how paints cure. A lot of guys will paint up until like late in the day, and then when the sun goes down, they don't realize that the humidity in the air gets so high that there's so much moisture vapor in the air that there's no place for the water in the paint film to escape. So if you look at all those little red little molecules above the paint film, that solvent that's in, or water that's in the air, and then you've got the solvents that are trapped in the paint film, and if they can't escape, the paint stays soft. So you see the little sad faces of the paint film that says "Game over, man." And then you look at the solvent molecules saying, "Hey, it looks pretty crowded out there. Let's just stay home." So that's the problem, is that a lot of people will look at temperature and think that's the main thing they need to get paint to dry. And it's really humidity that sets people back, because when you get very high humidity over 85%, typically at that point, the air is so supersaturated that paint film will never start evaporating. It'll make all the paint stay wet, and it might, in some cases, even absorb back into the paint to make the paint wetter and heavier, and that's when you get sagging and running and and that type of stuff when you get back to the job site the next day. So again, it's very important to pay attention to your weather underground numbers to know not only what the temperature is going to be during the curing process, especially overnight, but also what the humidity is going to be. So let's talk about additives. Again, additives are low volume products that do a specific task. So again, in the manufacturing of paint, we have things called thickeners or rheology modifiers. And rheology is the science of how a liquid tends to flow. These things are usually added very late in the manufacturing process because it's easier to mix everything up if the paint is very thin. So at the very end, we'll add these rheology modifiers to thicken the paint up. And again, they give you adequate viscosity or thickness so the paint can be applied properly, and they impact how thick the paint goes on and how well it flows out. Products like Manor Hall or Silk & Touch are made to flow and level very well. So there are rheology modifiers in there that keep them a little bit probably thinner in the can compared to some other products, but it makes it want to flow and level better. So if you're brushing and rolling, it makes it look like it's sprayed. There's other products like Timeless and Permanizer that have rheology modifiers that keep the paint from sagging, so that if you're spraying the product, you can build it heavy enough to possibly achieve the millage of 2 coats in one, therefore making it a very user-friendly product and it won't sag. So again, rheology modifiers are very important, and so you need to really understand what your customers are looking for. And if they're looking for flow and leveling, if they're brush and rolling, that's one type of product. If they're looking to build it on heavy, that's another. Surfactants are one that probably give people more problems because we have a thing late in the season typically called surfactant leaching, which is a bad thing. But surfactants are really one of the most important things that we have in a can of paint. These are literally specialized soaps. Think Dawn dishwashing liquid. They do 3 main things. They stabilize the paint so that it'll not separate or become too thick in the can. So that's very important. You don't like to have your paint separate, especially after you've tinted it and shaking it. So surfactants really help kind of hold everything together. The other thing they do is they keep pigments dispersed, and they aid in the compatibility with tinting colorants. So again, when you're tinting paint and you think darker bases, like a deep tone or an ultra deep base, you have to have surfactants in there to disperse and break up that colorant, kind of like Dawn dishwashing liquid will break down oils or grease on your plates or dishes or something like that. Those same types of soaps break up and aid in the pigment disbursement so you don't have globs of pigment after you shake up the can. The third thing that's probably really one of the most important things that surfactants do is they help wet the surface. Think about when you're spraying a wall. If that paint started to crawl or fish-eye to where it started pulling away from itself, you'd have all these holes in your paint film that would look terrible aesthetically. So what surfactants do is they literally help wet the surface, start wicking into the substrate, but it holds on to itself so that the paint doesn't pull away or crawl. Biocides come in 2 different types in the can. There's preservatives and there's mildicides. Preservatives keep bacteria from growing in the can. So if you think about a water-based product that's very low VOC or 0 VOC, you don't have the same type of solvents like mineral spirits and ethylene glycol that would normally kill mildew spores in the can. If you've ever smelled a can of paint that went bad, it's because there just was too many mildew spores for these biocide preservatives to keep killing them. So when paint goes bad, it's a kind of a memorable event. When you have that smell, you can really remember it for a long time. But without preservatives in the can, we wouldn't have the average of the 2-year shelf life minimum that most paints do. Mildicides in the can discourage mildew growth on the paint film. They're not as active to where it kills mildew spores on contact, but by being embedded in the paint film itself, it makes the paint film less hospitable for mildew spores to start growing. All of our exterior paints typically have a very good mildicide package in it, and products like Permanizer and Timeless have multiple mildicides in there for different parts of the country. So very important to have those in the can. Since we have specialized soaps in a can, if you didn't have defoamers, as you shook up your paint, you'd have all these bubbles. So because we add surfactants to the paint to do certain things, we also have to add defoamers so that you don't have these bubbles when you spray or roll on. Again, aesthetically, that can really mess up the paint. So that's important. And then the last thing that we have are co-solvents. We might add tiny amounts of solvent that aren't part of the big solvents in the picture. They're additives because they're specialized ones that aid in the binder in forming a good film, and they help the paint from freezing, like those glycols, kind of like antifreeze. So again, those are very important. With the push in the industry for these low and no VOC products, remember that when you're storing them or transporting them, that they will freeze more often because they just don't have the amount of solvents that paint years ago used to have. So you have to be a little careful with that. So sheen levels is really a big deal. So in most companies, and again, it depends on the product that you're using, you typically have a flat or a matte finish, and then you might have a washable flat, which could be called a velvet. The next step up would be like an eggshell paint, in England, they call it a pearl finish, which is like a high sheen satin. And then you've got semi-gloss and you've got high gloss. So the one thing that this slide's trying to show, if you look at the blue box on to the right, if you're looking at a gloss sheen type, the typical PVC, and what PVC stands for, it's the pigment volume concentration. It's the ratio of pigment in the can to hit a certain color versus the binder in the can to encapsulate those pigments. So the higher the sheen you have a less ratio of pigment to binder. It means you have more binder than pigment. As you drop down to a semi-gloss, you have a higher level of pigment in the can. You get to a satin finish, and again, these are theoretical, you have a higher level of pigment. Eggshell has an even higher level of pigment, where flat has the highest level of pigment volume concentration in relation to the binder. And we'll break that down again here in just a minute in another slide. This bottom picture shows how paint gloss is measured. So we have a piece of polished glass that represents the baseline of 100. And so if you look at the very lower right-hand side, you see 85% or 85 degrees. So that's one way that we measure paint sheen, because we have to get that close to the wall to see light coming across the surface. As you get into your higher sheens, you look at them and measure them in units at 60 degrees. And that's typically for your semi-glosses and your high glosses. I'm not sure what the 20-degree angle is used for. That's almost directly looking at it, but for the most part, very, very high glosses, would be very visible at that 20-degree angle. So again, gloss and sheen are basically used interchangeably from a terminology standpoint, but they're basically measurement of how light paint films reflect at certain angles. So again, architectural paints are basically measured at 2 points. So if it's 85 degrees looking straight down at the surface, for a gloss, 60 degrees is less of an angle and 20 degrees is almost directly. So that's just what I was talking about on the last slide. So this is just a general, kind of a general industry standard, and every company kind of measures their paint a little bit differently sometimes. But if you have to use the Master Painter Institute or MPI manual, many of those products are categorized by what those sheen levels are. So a flat sheen, if it's a dead flat, will be very close to 0. And that range goes from 0 to 10 units measured at that 85 degrees, which is the closest to the wall. You have to get close to the wall to see any type of light coming across a flat paint. And if it's a 10 unit, that's going to be a fairly shiny flat, almost like an eggshell. Typically washable flats are at about 5 units, and then anything over from 5 to 10 would be a very washable, scrubbable flat. When you get into satin and eggshell, it also is measured at 85 degrees, but it's a bigger range. It can be from the 10 unit measurement all the way up to a 30 unit measurement, which would be a very high eggshell sheen. When you get into semi-gloss and gloss, it's got the widest range, and now you're getting farther away from the wall. You're looking at 30 to 80 units. So some semi-glosses might be as low as 30 units, which would almost make it a satin, and some could be as high as 80 units, which would definitely make it a high gloss. And so again, this is something that is very inconsistent, I guess I would say, within the industry, that even within our own company, you might have 5 different interior products that all say eggshell or semi-gloss, but none of those products would ever touch up the other one, because they could be anywhere between that 30 to 80 unit if it is a semi-gloss. So again, that's something that, there's no way to really kind of control that as far as that goes. Every product is built for a specific reason. But in general, the higher the unit of sheen that you have, the higher the durability, washability, scrubbability you get. So again, as you go from flat to eggshell to satin to semi-gloss to high gloss, you get more reflectivity from those higher sheens, but you get a very much higher level of durability. So again, gouache and sheen specifications vary by company and typically even within every different product line. And again, MPI is the only entity that regulates sheen by product grouping. I just had one guy yesterday that was looking for a 144 sheen level, which was gloss level 3. And the Architect, we didn't have a product in there, but Pure Performance Eggshell is in 145, which is gloss level 4. And so it was 2 and 3 instead of 3 and 4. But anyway, you have to just be careful that some products may or not fall in, as even though they should be a direct performance equivalent, the sheen levels might be ranked by MPI just as such as they may not be in the same category. So you need to have that discussion with people sometimes. So solids by volume is probably one of the most used bits of information that we have on data sheets. A lot of people try to look at the solids by volume to see how good the quality of a product is when you're comparing apples to apples. So what solids by volume is, it's equal to the binder plus the pigments. So once the solvent evaporates, solids are what remains on the surface once the paint dries and cures. So again, a higher solids content will give you a thicker film when you apply it at the same uniform mill rates. So what that really means is the higher solids of a quality latex paints gives you a thicker dry film for better hiding and durability. So if you look at the can on the left and it's a top quality paint, you know, that top quality paint, depending on what product it is, could be about 30% solids all the way up to about 45% solids. So again, the light green color is the solvent that's going to evaporate, and what's left is what's left on the wall. When you get ordinary paint or entry-level product price points or primers and things like that, typically they're less than 30% solids. So an example is if you took both these cans of paint and applied them at 300 square feet per gallon, you're going to have a thicker paint film with the top quality paint because the higher volume solids will leave a higher dry film thickness on the wall. So again, that's what helps wet and dry hide. That's what builds things to quicker film thicknesses, because typically to get to that ultimate sheen level on a can of paint based on the data sheet, you need about 2.5 to 3 dry mills on a sealed substrate. So again, top quality paints, especially paints that are 100% acrylic and usually say paint and primer and 1 on them, are going to build to that ultimate mill thickness to get up to that ultimate sheen level to aid in touch-upability and things like that. Where with ordinary paint, it would take 2 coats to get to that mill thickness. In some cases, 3. So this slide probably shows it the best. So again, pigment volume concentration, or PVC, again, it's the ratio of the pigment to the volume of pigment and the binder together. So the higher the PVC indicates a better hiding product with less durability. I don't know if that says that right, but if you look at these cans on the right, so on the right-hand side, you see the gloss paint, which is on the upper left. And so the light gray is the resin, the white is the pigment, and then the solvent that says 65% is what's going to evaporate. So if you look at those top 4 cans plus the one on the left, the ordinary flat paint, they all have 65% solvents in them, which means they're all 35% solids products. But again, it's this pigment to volume ratio. So a high gloss paint theoretically has 27% binder or resin encapsulating 8% of pigment. That's going to give you a super durable, super washable and scrubbable finish. When you go to the right and you move to the semi-gloss paint, now it's only dropped down 1 percentage point of binder or resin. So you've got 26% of binder encapsulating 9% pigment. So you don't lose a lot of durability or washability with a semi-gloss, but it does aid in hiding surface imperfections a little bit. When you drop down to the middle left with the satin paint, now you're getting a little bit closer together. You've got 23% of the resin or binder encapsulating 12% of the pigment, so that sheen is less, but you still have a very washable, durable finish. When you get into a quality flat paint, like a washable, scrubbable flat, now you're almost 50-50. You're at 20% resin to 15% pigment. So again, you've still got something that's washable because you've got a higher percentage of resin or binder encapsulating those color pigments. But when you get to an ordinary flat paint, now it flips over. Now you've only got 16% of binder encapsulating 19% of the pigment. So now it's not going to be very washable. In fact, it's probably going to feel a little bit more rough. It's a little bit more porous. The film's not as tight because the pigments are a little more absorbent. So stains have the ability to sit on the paint film and start to migrate into the pores. So again, that's why ordinary flat paints aren't that washable. When you step into that last can of paint on the right, now you've gone up to 75% solvent. So now 75% of that can of paint is going to evaporate away, leaving only 25% volume solids. And now you've only got 6% binder encapsulating 19% pigment. So that's going to be something that's a very entry-level product, new home construction, a maintenance product, where it's literally not going to be washable at all. It'll touch up great because flat paints scatter light very exclusively to where, you know, they don't show any sheen level whatsoever. But you're not going to have the durability that you would with any of those other products. So basically that is Paint 101. So we're really thankful that everybody was able to be on here. We're going to have a Q&A session here coming up for the last 15 minutes, but we want you to mark your calendars for these upcoming training webinars. So in a few weeks, on Friday, October 5th, we're going to have a preparation and applicators webinar. On Friday, November 2nd, we're going to have an interior products and ceiling paints webinar. And on Friday, December 7th, we're going to have common paint problems. So again, we want you guys to save the date. Keep an eye out for our reminder emails that are going to be coming out. And again, if you have any questions now, or if you haven't submitted them yet through the Q&A, let's see, I would open it up to Kate to let me know if there was any questions submitted. Kate, go ahead.
Thank you. We did have one question come in so far, but please continue to submit your questions through the Q&A panel. And also, you can use the chat panel to send a message to all panelists. Give us some feedback about what you thought about today's webinar and any topics you'd like us to continue to talk about in the future as we schedule out more of this training series. We started with Paint 101 to really start building the foundation, and we'll move into more advanced topics as we go along. So for our Q&A, the first question submitted, is paint thinner the primary solvent in stain products like Flood and Prolux brands?
Yes, it is. Most of those are well, I take it back. It depends on the product line. Many of them are a blend of an acrylic resin and an alkyd resin, but they're in a water-based vehicle. And so there's only a few products that I can think of. The alkyd semi-transparent, and then the pure alkyd toner products where paint thinner would be the primary solvent. The rest of those are a modified oil, acrylic oil resin, but they all clean up with soap and water. So that's the key thing. When you look at a product data sheet and you're trying to figure out what the main solvent is, go to what the cleanup schedule tells you on the data sheet. If it says clean up with paint thinner is the main solvent. If it says clean up with soap and water, then water is the main solvent. Good question.
Thank you. Additional questions were submitted about how this presentation will be available. Today's presentation has been recorded, and we will send that out to all registered participants and actually all invited participants. So you will be able to view and share this information. Due to size restrictions, we may be sharing this as a cloud-based item that you can download. So more information to come to that, but all webinars that we do will be recorded and shared with everyone who was invited. We'll go ahead and we'll leave this open for a few more minutes if you'd like to submit your questions and comments about what you thought about today's content.
Thank you, Kate. And again, going forward, if you have any questions, please don't hesitate to reach out to any of us in the product training department. Kate Ross, Bob Johnson, Austin Pitchock, and myself are all available to you guys. So just don't hesitate to reach out. We want everybody, you know, really understanding the business very well. And again, product is a big issue for us.
As additional questions come in, we have people that are saying that they're very much enjoying the Paint 101 content. They want to know if we'll be able to bring them more PMC content in the future, an introduction to PMC basics.
At some point, I'm sure we will. We want to kind of build on the continuum of product knowledge, but we are the architectural product training group. So PMC is actually a different business unit, but we're in constant contact with those guys. So again, that would be something that we can probably work with them to do in the future. And for training on PMC right now, I would reach out to your local PMC rep for your market.
Okay, well, we thank everyone for joining us today. We will send you a copy of today's presentation. We will leave this presentation open for a few more minutes if you'd like to continue submitting questions. And for those of you that do need to jump off, thank you for joining us, and we will see you again the first Friday of each month from 3 o'clock to 4 o'clock p.m. Eastern Time.